So this is section 10.4, and I'm going to take a little bit of a detour before we start getting towards the meat of the section, the stuff that you're going to see in Newton. But the stuff that I'm covering on this handout is fair game for the test. I don't think you'll find it too bad. In fact, I think you'll find it to be a good skill to have moving forward in your math classes. And what I'm going to ask us to do first of all is to get acquainted with the graphs of a few functions. So for instance, this one would be the graph of y equals x squared. Now, if we hadn't already had this graphed, then one way you could approach trying to figure out what the graph looks like would be by simply plotting some points. So 2 squared is 4, 1 squared is 1, 0 squared, negative 1 squared, and negative 2 squared. So let's plot these points. That gives us certain pairs of points, and I'll put those on the graph. Starting with 0, 0 is what's called the vertex. I just chose a random selection of x's, not exactly a random selection, symmetric set of points around 0. And then I put them into the function x squared. 2 squared, 1 squared, 0 squared, etc. So 0, 0 is a point. 1, comma 1, so 1 for x, 1 for y. Negative 1 for x, 1 for y. 2 for x, 4 for y. And then negative 2 for x, and also 4 for y. So I get those 4 points, and you kind of basically play connect the dots in a college-educated way, and you get this nice graph of a parabola. We're going to do likewise for two other functions. So the first of them is y equals x cubed. Now on both ends of this I'm going to draw a little arrow because this graph doesn't stop miraculously. It keeps on going forever. But we're going to do the same thing here. This time y equals x cubed. What's 2 cubed? 8. So 2 and 8 would be up here. 1 cubed, of course, is 1. So 1 and 1. 1 is halfway between 0 and 2, so 1 and 1 is really right there. 0, 0 is a point on this graph again, just like it was on the previous one. Negative 1 cubed is negative 1, and negative 2 cubed is negative 8. So down here someplace. So we get these points. And it traces out a much different pattern as you work from left to right. The last one. Does anyone recognize the function that's graphed here? Thank you. Y equals the absolute value of x. Absolute value is going to make everything positive, so this should be 2, 1, 0. Absolute value of negative 1 is 1. And absolute value of negative 2 is 2. If I plot these points, I'll get 2 and 2, 1 and 1, 0 and 0, negative 1 and 1, and negative 2 and 2. So there you go. 3 basic shapes, 3 basic graphs that I would expect you to know. But here's the thing. A lot of times you're going to get functions that are similar to this, but not exactly this. And it's a good skill to be able to look at the function and know what its graph looks like. So this is where we're going to use Desmos. Let's start by graphing both of these. Y equals x squared and y equals x minus 3 squared. So click over to Desmos. And that'd be right here. Let me get rid of this function here. So I'm going to type in y equals x squared. Now to get the square key, you've got two options. You can hit the shift key above the 6. So shift and then 6. And I got to change this up a little bit. Yours might look a little different at this point. Let me go from, say, negative 5 to 5. And negative 10 to 10. All right. How do you get what? All right, so you can hit the shift key and then type the number 6. Shift 6 will give you an exponent, and then you can type in the square. Or there's a little function palette little keypad down here, and you can type in the square key by hitting this, the a squared. So that'll give you a quick square. So here's your graph of y equals x squared. Do you think the graph of y equals x minus 3 squared is going to be really different? Is this going to be a wildly different graph, or is it going to be similar to our graph of y equals x squared? Should be similar, right? Should be related somehow. Let's see if we can't figure out how. So let's type in that second graph here. The nice thing about your graphing calculators or Desmos is you can type in multiple graphs. So x minus 3 in parentheses squared. So what happened? What happened to our graph of one versus the other? It moved to the right by 3. Good. So, nice. That's a nice observation. So this one got shifted to the right by 3. Let's write that down. Shifted right by 3. Now that we've seen that first one, maybe you can make a prediction for the second one. This one is x plus 2 squared. How do you think that one's going to be shifted compared to x squared? To the left 2. Thank you. So let's see if we're right before we write it down. So we'll go here, and I'm just going to go back and change this plus 3 or minus 3 to plus 2. And there you go. This graph has now been shifted to the left by 2 compared to the original graph. So knowing the shape of this one, the first one, y equals x squared, we really know what the shape of a lot of graphs are because we can shift these things in our mind. And that's the skill that I want you to have. So this has been shifted to the left by 2. Let's play a different game. What if I add x squared plus 3? Got a bet for up 3? Let's find out if she's right. So let's get rid of this. X, oops, I don't want a capital X. You need a lowercase x. And then you can hit the squared key down here, plus 3. What happened to this graph compared to the original? Shifted up by 3. So just like we predicted. So shifted up by 3. Yeah, and a good prediction would be that this one would be shifted down by 4. And you can double check it on Desmos or your graphing calculator to see that you're right. It is going to be shifted down by 4. So let's just make that a minus 4. And boom. Shifted down by 4. Notice that the vertex is now at 0, negative 4, whereas before it was at 0, 0. Okay, now that you got the basics down, let's go wild, right? Ooh, what's going on with this one? Good. Left by 3 and down by 1. Left 3, down 1. So this is cool. You can start to predict these things and know in your mind what the graph will look like. And the good thing about that is that when you're trying to input this stuff into some software or your graphing calculator, sometimes you make mistakes. And when you hit that button, if it doesn't look like what you expect, you go, wait a minute, something doesn't look right. Because you know what what it should look like. Let's do another change on this. What if I put a negative in front of that x squared? How's that going to make the graph look? Perfect. So if I put a negative here and then an x squared, it's going to reflect it around the x-axis. So basically it opens down as opposed to opening up. So it's flipped or reflected around the x-axis. A couple ways you could say that, but I think the easiest thing to say is flip or opens upside down. So opens down slash flipped. A couple things that I would accept there. But the bottom line is that if you have a negative in front of your square term, your parabola is going to open down as opposed to opening up. So So a couple things to note out of all this discussion. When you're looking at this in general, what is the H control? H is going to cause a horizontal shift or a vertical shift? Good. H is going to cause a horizontal shift. What's K going to do? K is going to cause a vertical shift. Nice. So there's one of a couple ways I can ask questions like this on an exam. I could give you the equation and ask, well, how is it shifted? Or I could give you the shift and ask for the equation. Like in this one. I want a parabola that's been shifted to the right by 3 and down by 5. So y equals something squared. What would be that something that gives me a right by 3 shift? X minus 3 squared. Good. Keep the square. And then the down 5 would be the minus 5. Nice. There's two more like it here. So see if you can't figure out what the equations would be based on the description. You take your standard parabola and shift it. What's that new equation going to be? Both of them. This one and this one. Both of those. Giving people a chance to think it through. And then I'll pick on Chantel. Chantel, thanks for volunteering. How about this first one? Want something that's shifted to the left by 6. So what's going to go in the parentheses? What's that? X plus 6, good. And up by 15. Plus 15, excellent. How about a volunteer for the last one? Kayla? What's this last one going to look? This one, the last one.
Y equals negative x plus 91 squared minus 50.
Perfect. Nailed it. Wow. Excellent. So the negative is going to make it open down. Plus 91 shifts it to the left by 91, and minus 57 shifts it down. Wow. Good job.
How do you know where to put the square?
Well, because I'm working with shifting a parabola. And a parabola function, parabolics, are going to have a squared term. If I was working with the absolute value, then I would have had the absolute value. But I'm trying to shift a parabola.
How would you know when it's shifted left or right?
It's a good question. How do you know if it's shifted left or right? Well, the thing about the horizontal shift is that it takes place opposite this sign. So minus 3 is shifted to the right by 3. Plus 6 is shifted to the left by 6. So it kind of goes opposite of what the sign here tends to suggest. So a plus 91 is not to the right by 91, it's to the left by 91. So that's how that works. The negative out in front doesn't change this. You don't distribute this or anything fancy with that. You just put the negative out in front of your squared term, and that causes it to open down. So
The plus or minus will determine the left.
yeah, plus or minus determines left or right.
A negative like in front of it.
Yep. The negative doesn't change this. It doesn't make this shift to the right all of a sudden. It's still going to shift to the left. Yeah. Let's flip this over and work with a different function. And now I'm going to quiz you to find out if you really know your shift. All right. So now we're going to work with the absolute value. But the idea is still the same here. So if instead of looking at the graph of y equals the absolute value of x, if I was looking at y equals the absolute value of x plus 2, how has this graph been shifted as opposed to this one? Yeah, to the left by 2. And you can check these on your graphing calculator, or you can check them on Desmos or whatever you want. Let me show you how to do this on your graphing calculator, just for the sole purpose of showing you how to do an absolute value on your graphing calculator, because that's not something that people go to very often. If I wanted to graph this, I'm going to hit the Y equals key, and now I need to type in the absolute value. So where's the absolute value? Well, so we hit the Y equals key, then the math key. Then I don't see anything here, but if you cursor to the right by 1, then the first selection is for your absolute value. If you got an old TI-83, it'll probably just say absolute value, ABS, and then parentheses. But if you got something a little bit more up to date, you'll actually get the absolute value. So I'll just type in an X here. And in comparison, let's do the absolute value of X plus 2. So to remind ourselves, it was the math key, then to the right ones, and the first selection is the absolute value. This time I'll type in an X plus 2. And now I've got both equations. I have to tell my calculator where I want to see this, what my window is going to be. So along the x-axis, let's go from, say, -4. Let's go -6 to 6 on the x-axis. And since the absolute value in this case is going to be positive, I'll go from 0 to 4. Let's see, 0 to 4. Let's try 0 to 8 on the y-axis. And let's graph it. So there's one, and there's the other one. Notice that our second graph was shifted to the left by 2. So it matches what I expected. I can't see that from here. Error. All right, so if you're getting an error, there's a problem between the calculator and the chair. Wah, wah, wah. No, if you're getting an error, come let me see your calculator at some point, and I'll see what we can do to help you out there. It did get shifted to the left by 2. Let's try some of these other ones. Absolute value of X plus 1. How's that one going to get shifted? Up by 1. Kind of a double shift going on with this next one. So first would be left 4. Left by 4. And then what? Up by 3. So, no, you're not going to get practice problems like this on Newton. So, because I'll test you on it nonetheless. I don't know, somebody gave you a handout that you can practice on. And there'll be more problems that we're not going to do that you can practice at home. Let's finish up this one. What's the negative going to do? All right, so it's going to open down. Opens down. Or you can say flipped. Or you can say reflected around the x-axis. I chose opens down. And then what else? Down by 4. Yay. So, how are those? Are those okay? Those are some friendly problems? You would shift to the right if I had something like y equals the absolute value of x minus 5. That would be a shift to the right because there's a minus here as opposed to a plus. And then it would be shift to the right by 5 and up by 2. So it's stuff that's inside the absolute value that's going to cause a horizontal shift. That causes shift to the left. No, it's shift to the left 4. The horizontal shift is opposite the sign. So plus 4 instead of being to the right is actually to the left. Minus 5 is actually to the right, not to the left. So the horizontal shift is opposite of the sign. The vertical shift actually goes like you would expect. Plus 1 was up 1. Minus 4 was down 4. So the vertical shift matches your expectations. It's the horizontal shift that you have to be a little bit more careful about.
Say the near the horizontal one again.
The horizontal shift shifts in the opposite direction that you might expect. Plus 2 would be shifting to the left by 2, not to the right by 2, to the left by 2. Likewise over here, plus 4 shifts to the left by 4. If I had a minus 5, that'd be shifted to the right by 5.
So if it was x minus 4,
If I had y equals the absolute value of x minus 4, that would be shifted to the right by 4. So, yeah. Now you can play with these things on, excuse me, you can play with these things on Desmos, or your graphing calculator. Here it is on Desmos. So let's do the absolute value of x and y equals the absolute value, and I think there's an absolute value, probably an absolute value here in the function palette someplace. Oh, here you go. Absolute value of x plus 2. So there you go. So one's been shifted to the left by 2 compared to the other one. Okay. Let's move on from that and get a little bit closer to stuff that's in Newton. When you work in Newton, you're going to get problems that ask you for the maximum or minimum of some kind of a parabola, like this. So, do you recognize this scene here from Angry Birds? Yay! The thing about working with Angry Birds is that parabolas can actually be made to order. You can really shape them to fit what you want. So let me turn back on the graph here with some new values. There we go. I've got a parabola that starts out at the origin. But what I'd like to do is I'd like to make my parabola fit what I have here for my Angry Birds. So there's a couple things I need to do. The first thing I need to do is I'll shift this up here so that its vertex is in the right spot. So that means changing this value. So let's shift that up. And that looks pretty good right there. Maybe I need to shift it over a little bit so I can do a horizontal shift. It's H that changes the horizontal axis. So there. And now I need to change its shape. So the shape of this is controlled by this number out in front here. So I can make that number bigger, which makes it narrower, or I can make it smaller, which makes it wider. And something magic happens when I pass 0. When this number becomes negative, what's going to happen to my parabola? It's going to flip. So here's the magic. Boom, it flips. And now I just got to keep dialing this down a little bit until I match something. And that looks pretty good. Let me make it a little fine-tuned. Pretty good. So the nice thing about your parabolas is you can really make them match lots of different things here. What's that going to mean for us in terms of Newton? Well, in Newton, you're going to get problems that are going to ask you for the coordinates of your vertex. There's going to be a couple things that you're going to want to know. You're going to want to know the x and y coordinates of the vertex. So let me start there. And this is your Newton work for section 10.4. You know what? Did I hit the record button?
I don't know.
Yeah.
Okay. All right, that's good. So section 10.4. So I want to find the x-coordinate of the vertex to this parabola. Y equals ax squared plus bx plus c. So the x-coordinate of that vertex is given by a little formula. Is given by x equals negative b over 2 times a. So if we find those coefficients of A and B and plug it into this little formula, then you'll have the x-coordinate of the vertex. To get the y-coordinate, by plugging in the value for x. So once you know the x-coordinate, this formula, you get the y-coordinate by plugging in the value for x into your original equation.
Isn't that like your radius?
No.
Isn't it r over 2a or something?
No. It's not really related to radius at all. But thanks for trying. So let's start with this example from the book. So a ball is thrown from the top of a building or something like that, and its height, dependent on time, is given by this equation. Y equals negative 16x squared plus 48x plus 28. So if I want to figure out when it's going to reach its maximum height and what that maximum height is, then I need to find the vertex. Let's take a quick look at this on Desmos. So let me shut this graph off. You know what? Let's see here. Yeah, I got another one over here. So y equals negative 16x squared. Now what's that negative 16 do? That means it's going to open down. Plus 48x plus 28. Now in this case, my graph doesn't quite fit what I have room for here for. So if you hit this little toolbar, you can change the value for y. So the maximum value for y, let me bump that up to 80. This should be good enough. And now it fits. So what I want to find is this point. I want to find the coordinates of that point, because that's where the ball reaches its maximum height. So what is that maximum height and where does it occur? Let's find out. X is going to equal negative b over 2a. In this case, what's b equal to? 48 over 2 times negative 16, which is negative 48 over negative 32, which is 1.5. So that's the x-coordinate. Let's check out what the y-coordinate is going to be. And to do that, let me take 1.5, and I'm going to store it in x. So store in x. And I'm not going to break a sweat trying to calculate this because I'm going to let my calculator do it. Negative 16x squared plus 48x plus 28. And there you go, 64. So that's the y-coordinate of your vertex. That's the maximum height of this thrown object. So y equals negative 16 times 1.5 squared plus 48 times 1.5 plus 28 equals 64. Now in Newton, they would describe the problem carefully to you. This would be your height. In this case, it's in feet. So 64 feet. What do you suppose the 1.5 is? It's your time. In this case, it's going to be time in seconds. So 1.5 seconds. If you happen to graph this on Desmos like I did, kind of the cool thing is that if you click up here at the top near the vertex, it should hone in on it for you. So there you go, 1.5 and 64. A nice way to kind of double check your answer before you type it into, I don't know, Newton. That way you don't get set back because you made a rounding mistake or something like that, double check your answer before you move on. How's that one look? Doing okay on that one? Let's try some more here. Did I show you the answer already? I'm so bad. Yeah. I don't think it was that memorable that you memorize it yet. If you're watching at home, I'm sure you can backtrack on the video and figure it out. But let's try and do this the right way. So a ball is thrown up from the ground with an initial velocity of 122 feet per second. Use the quadratic function h of t equals negative 16t squared plus 122t plus 0 to find out how long it will take the ball to reach its maximum height. And then find the maximum height. Round your answers to the nearest tenth. Bless you squared. So h of t is negative 16t squared plus 122t. Well, this gives you your a and the b. I don't need to write the plus 0. I mean, that's going to be my c. But c is not part of this formula, negative b over 2a. In this case, maybe I should put t equals negative b over 2a, because really we're working in a parabola that depends on t. But what's that going to be? Over 2 times what? So negative 122 over negative 32. And I can get rid of the negatives. In fact, I can put that in lowest terms if I'd like.
So is that something that you're gonna want, or if Newton wants?
Well, let's see. I get the number 3.8125. And I could turn that into a fraction if I wanted to in lowest terms. 61 over 16. Basically, you're dividing out the 2 here. But for now, let's just keep it around at it's 3.8125. What's that 3.8125 telling us? How long it takes till it reaches its maximum height. It doesn't tell us what the maximum height is. It tells us how long it takes to reach the maximum height. How am I going to figure out what that maximum height is? Plug it in. So you're going to take h of 3.8125, 3.8125 squared, and then 3.8125. I think the easiest way to do this is, again, on your calculators. So I'm going to take this value and hit the store key, store that in x, and then do negative 16x squared plus 122x. Oh, and this is annoying. Gave me a decimal. 3721 divided by 16. There we go. 232.5625. You guys getting the same thing?
Yes.
Okay, good. So 232.5625. So that's the other, yeah, that would be in feet. Now here's the annoying part. So this is in seconds, that's in feet. Newton's going to want these answers, but then you have to round them. And this would be some of my feedback to Newton if they were tuning into my videos, which of course they should, but you know. Yeah, they'll tell you. In fact, let's take a look back at the problem. Round your answers to the nearest tenth. But if you accidentally round it to the nearest hundredth, it's probably going to mark it wrong. I'm just guessing. Yeah. So you should be inputting in the maximum height is 232 point. Well, if I round this to the nearest tenth, is that going to be 5 or 6 there? 6. So approximately 232.6. And of course, it fills in the feet for you. And then to the nearest seconds, that's approximately 3.8. So be careful. As I was doing some of the homework, I got dinged on that. I'm like, oh, are you kidding me? But whatever. It's asking for the nearest tenth. Give it to the nearest tenth. Everyone will be happy. Are you comfortable with these types of problems where we're trying to find the vertex? Okay. All right. There's other work that we can do in graphing these things and in working with these things. Finding the vertex is an important part of this. In fact, this should be your first goal, because that's really what defines these graphs, is where is the vertex. If you have the vertex, you're in good shape. Let's switch over to Newton here. Okay, so it gives me this equation. Y equals x squared plus 4x plus 4, and it tells me to graph this thing. Now, it's giving you some points, and what you're going to do is drag these things around and see if you can't figure out what the graph is. But it's telling you to start by dragging this to the vertex of your parabola. Now, I know that this is wrong. The graph here is wrong. How? How can I tell that's wrong? Yeah, it's going down, right? The coefficient of your x squared term is positive, so it has to open up. So I know that this is not the right graph. Let's see what we can figure out with this. See if we can't try and make some headway. So let me copy down the problem here. So we've got y equals x squared plus 4x plus 4. And we're going to keep track of several points here, some important points. The first one I want to find is the vertex. So to find the vertex, I can do this. Negative b over 2a. So Ryan, help me out. What number should I put in for negative, or for b and a? Good. So it's going to be the negative of 4 and over 2 times 1. So I end up with negative 2 for the x-coordinate of my vertex. Nice. Alex, I need to find the y-coordinate of my vertex. Yeah, plug in negative 2. So negative 2 squared plus 4 times negative 2 plus 4, and bingo, I get 0. Let's keep track of some of these important points. Negative 2 and 0. That's a good point to know. Another good point to know would be my Y-intercept. So let's find the Y-intercept. Let's look back at our graph here for a second. It's nice to have a nice visual of this. The Y-intercept is where the graph crosses the y-axis. What can you tell me about the x-coordinate along the y-axis? Equals 0. So what we'll do to find the y-intercept is we're going to set x equal to 0. So if I put in a 0 here, y equals 0 squared plus 4 times 0 plus 4. I hope we don't need our calculators on that one. 0 and what else? 4. So those are a couple good points to start with. And let's see how far that we can get with those 2 points. Now it suggests us that we need to start by plotting the vertex point first. So that vertex is going to be at negative 2 and 0. So let me put that up here at negative 2 and 0. And then, what else do I have? Got a couple more points. And let's see. Negative 2 and 0. At least it's pointing the right way now. Why is that not working? What's that?
Same thing happened to me. I couldn't figure out.
Yeah. I don't blame you. So, um, let's see here. Let's. All right. So I think part of the problem was that this point was not between these two. Let me see if I can. Let's see. So, no, that's not looking good. -2. Yeah, boy, this isn't helping me out here. Come on, guys. I know what this graph should look like.
Is it like one of those green balls moves up and down, the other one moves left and right?
Well, let's see. Uh-oh. Uh-oh. Now I'm toast. Oh, boy. I wonder if I can recycle this one. I did. I found out a new problem. Um, let's see here.
I was gonna say.
Let's try it again. Unfortunately, they're part of the homework, and I'm not sure what to do around this. Let me try this one more time.
Let's not do homework.
The orange one's the vertex?
The orange one's supposed to be the vertex, right? Says use the orange key point as your vertex when graphing. Plot the vertex first. So, try the other blue one. Let's see. Well, the orange one has to be between these two. So let's move this over. It's not letting me move that one over. So that's the problem, is it's not letting me move this over.
If you put it at the vertex though, can't you move it another one on the right? Can't you flip it?
How about if I move that one over here? There we go.
Oh, and somewhere.
All right. All right, so we got the vertex over here. I had to flip this one over here. That was a pain. Sorry. But hopefully, seeing me suffer through it, we can figure out what was going wrong. So we got this one here. What was the other point that we had? 0, 4. So let's make this one up here 0, 4. And notice what it's doing. It's giving you this symmetric point because parabolas are symmetric. So I've got one here at 0, 4 and another one at the same height, just 2 to the left instead of 2 to the right of the vertex. So you've got a point at -4 and 4 as opposed to 0 and 4. And that should work. Hold your breath. Booyah! Yay!
That one's way too complicated.
Well, that's because it was our first try at this stuff. All right, let's try another one. So let's continue. Okay, so let's try this one. Y equals x squared plus 6x plus 8. So let me copy that down. Y equals x squared plus 6x plus 8. And we'll actually be able to do a little bit more with this one. As usual, we'll start by finding the vertex. So x is going to be -b over 2a. Bianca, what number should I put in to find the vertex on this one? Yeah. So basically, I get that the x-coordinate of the vertex is -3. Now let's find the y-coordinates. So it's going to be y equals -3 squared plus 6 times -3 plus 8. So that's 9 minus 18 is -9 plus 1 is plus 8 is -1. You guys getting -1 for that? Let's keep track of things over here in a little t-table. So at -3, I get -1 for my vertex. So negative 3 and negative 1. Let's get a couple other points, some easy points. So an easy point to get would be when x is 0. If x is 0, can you read off that point? What would the y coordinate be if x is 0? 8, right? 0 squared plus 6 times 0 plus 8, so 0 and 8. So that's the y-intercept. But I can also find the x-intercepts. How am I going to find the x-intercepts? Well done. Thank you, Lisa. Set y equal to 0. To get the x-intercepts, or the y-intercepts, I'll set x equal to 0. To get the y-intercepts, I'll set, or the x-intercepts, I'll set y equal to 0. So it's going to be 0 equals x squared plus 6x plus 8. Do I need to pull out the quadratic formula for that one? No. That'd be like squirrel hunting with a bazooka. All right. Let's do it a little bit more clever. What else can I do to solve this one? Factor. X plus 2 times x plus 4. And I get two solutions, right? What are they? Good. So, zooming out here, I'll put a 0 and a 0, negative 2 and negative 4. This is exactly what I want you to be able to do on an exam, is graph these 4 points. Let's see what that's going to mean on Newton, and I'm holding my breath on this one. Oh my gosh. All right, so it says move the points, move the key points to do the parabola, to create the parabola. So let's see here. We had a y-intercept at 8. So I'll put that one up here at 8. And now I'm going to want some x-intercepts at negative 2 and negative 4. So let's see here. There and there. Hey, that one didn't work out too bad. All right, so wait, negative 2 and negative 4. I didn't have it right to begin with. So let's just double check these. I think if you click on them, it'll give you the coordinates. Do all the coordinates line up with what we think they should? Yeah. Let me see if I can click this one and undo it. Take a look at the vertex. Negative 3 and negative 1. Everything looks like it's matching what we expect it to. So let's declare victory and go home. Yay! All right. No, not for real. Sorry, I should be careful about what I say. No, we're not done. We're not done here. But we nailed that one. Yeah, we have some more time here. Let's try a simpler one. It says find the minimum or maximum of this function. Well, let's think about this function. Yeah, there's no middle term. That's okay. That's okay. It actually makes this one easier. Is this one going to open up or open down? I got a few downs and a few ups. Which one's going to open? Up. Well done. Thanks for making me look good. It's going to open up. So if it opens up, then our parabola is going to have to look something like this. Meaning that this vertex, is it going to be a minimum point or a maximum point? Minimum point. And that vertex has to happen at x equal negative b over 2a. I don't think we need to go that far in this one. We could. Our equation was y equals 4x squared minus 49. What's b in this equation? Yeah. 0 over 2 times 4 is still going to be 0. Huh. No, it's not undefined. Actually, let's see, I wanted to put a 0x. 0x minus 49. But yeah, we get a 0. If you plug in x equals 0, 4 times 0 squared minus 49 gives you what? Negative 49. That's your answer. So let's just plug it into Newton. So negative 49. And submit. Nice. It says I'm awesome. I mean, it says I got it right. That was close. Same thing. All right. Are we good with these? With these where you have to find the x and y coordinates of the vertex? Because that's all this one is. It's just another application of some of the stuff we've done before. I wish I could skip this one. If I hit... I can't hit submit. Just hit view answer. Type in the wrong answer. And I think you can probably crank out the correct answer pretty quick. There'd be 168 divided by 32, which is 5.25. So negative 16x squared. So here, I'll let you kind of follow along here. Negative 16x squared plus, what was it, 128? Let's look back here. Plus 168x plus 45. 486. So maximum height of 486. You know, I think I remember having problems with this one before. 486 after 5.25. So I'll call that a 5.3 seconds. Like I said, I think I remember having problems with this one. Oh, phew, got it right. All right. Last one for graphing, and then we'll be done with this section. Yes. No, it's not coincidence. What that comes from is physics. So, yeah, it's the force of gravity. Basically, the equation is y equals negative 1/2 g squared, or g times t squared plus your initial velocity plus your initial height. So g on Earth, if you're talking in feet, is 32. 32 feet per second is the acceleration of gravity, times the negative 1/2 gives you the negative 16. If you're working in meters, you'd end up with 9.81 meters per second squared. So, yeah, nice observation. We'll keep it in English units to be friendly. All right, so here's our last one for this section. We've got y equals x squared minus 2x plus 1. We want to graph this by plotting the vertex and the y-intercept and a point symmetric to the y-intercept. So it's not asking for the x-intercepts, which is good because those would be a little bit more of a pain. Let's flip over to this. Y equals x squared minus 2x plus 1. Let's first of all figure out the vertex. So 1 and negative 2. Candace, what should I put in for A and B? Good, negative 2 and 1. So what's it give me for the x-coordinate of my vertex?
2 and 2.
Which simplifies to 1. If the x-coordinate of my vertex is 1, thank you, Candace, what do I do to find the y-coordinate? I don't. Plug it in. 1 squared minus 2 times 1 plus 1, 0. Okay. Because it's 1 minus 2 plus 1 is 0. So this is what we got so far. x and y. 1 for x gives me 0 for y. And then the other thing it wanted was for us to find the y-intercept. So to find the y-intercept, what do I have to do? Set x equal to 0. Can you do that without your graphing calculator? If I plug in a 0 here, what do I get for y? 1. Good job, making me look good. Thank you. Let's work with those 2 points. So we got, let's see. This is use the orange point as the vertex. I guess we found the vertex, right? 1 and 0. So 1 and 0 there. And then we need to find another point, which is your y-intercept. So that one was 0 and 1. And last but not least, keep in mind that this point here is going to have another point which is symmetric to it on the other side of the vertex. So where's that point going to be? Well, if here's my vertex, I go up 1 and to the left 1 to find 1 point, then the mirror image would be to go up 1 and to the right 1. So I've got to bring this other point in to be that mirror image. And now it looks pretty good. Now let's take a look at it. Here and here, those are mirror images of each other. 0, 1, and 2 and 1. And there's my vertex. So looking pretty good. Are we ready to hit the submit key? Tell you what, there's another way that you could have envisioned this graph. And it actually goes back to the shifting that we did earlier in this section. And the way to envision that graph is to realize that this will actually factor as x minus 1 times x minus 1. But better than x minus 1 times x minus 1, what's another way to write that? X minus 1 squared. Let's think about this in terms of shifting. We know what the graph of y equals x squared looks like. What's the graph of y equals x squared, or x minus 1 squared, going to look like? Shifted to which way? To the right by 1. And if you look at your graph here, that's exactly what's happened. The graph has been shifted to the right by 1. Perfect. Just like we would expect. All right, well done. Let's take a well-deserved break, and I'll see you in a few minutes.